Here we are again at the end of our OSPF lab. We have bisected the network right in half, right here at Jack. Everything over here is Area 1, everything to the right is Area 0. So now let's look at the show IP OSPF command on Jack. Now it shows that we have 2 areas in this router. You might not have noticed this line before, but number of areas in this router is 2. 2 normal, 0 stub, 0 not so stub area. We won't get into the stub or not so stub area because, again, this is CCNA and they don't cover that here. So here is area backbone. We have 2 interfaces in this area because our local loopback network is also in this area. SPF algorithm executed 22 times. It was last executed 43 seconds ago when I ran this command. Here's area 1. SPF algorithm is executed 3 times in area 1. And it was last executed 39 seconds ago. So now Jack knows about all of the networks everywhere in the inner network because he is an area border router for Area 0. You notice that his route table does not look any different than it did before we made any of our changes. However, let's look at some of the other routers. Let's look over here at Jade, for example. If we do show IP route, we notice that we now have some routes in OSPF that are flagged as IA. If you look up here in the codes, IA is an OSPF inter-area route, meaning that I don't have that route in my local area, but I do know that I have to go through 192.168.2.1 to get there. The same down here for our point-to-point route. Some of them are now inter-area routes because I have to go across this area border router to get to it. So now let's run the same test we did before. So we're going to look at Dave and Jane, and we're going to shut down a network on Jane and see if it causes the SPF algorithm to re-execute over here on Dave. And if our theory is correct, it should not. So let's do show IP OSPF just to see how many times it's executed now. So now we have SPF algorithm executed 12 times. It last executed 5 minutes and 23 seconds ago. So now let's go over to Jane. First, let's go into config mode, interface loopback 1, and we'll shut that puppy down. So now it's changed to administratively down, the line protocol is down, and that network should no longer appear in any of our routing tables. Let's look over here on Dirk. If we do show IP route, we no longer should see the 10.10.3 network in our routing table, and we don't. It is gone because that network is down on its local router. However, let's go back over here to Dave and see if he has re-executed his SPF algorithm. SPF algorithm is executed 12 times. Last time was 6 minutes, 20 seconds ago. So you'll notice that even though this network went down over here on Jane, which again, San Francisco versus London, if you wanted to give 2 city names, it did not cause SPF to recalculate anywhere in Area 0. If we look at Dave's routing table, we do show IP route. He no longer shows the 10.10.3 network either, so he knows that network is down, it is inaccessible, but I don't know exactly which router it's connected to and which router went down because I don't have those LSAs in my area. Same thing if I go back over here to Jane and bring that network back up. Interface loopback 1, no shut. Once it comes back up and it floods the LSAs back here in Area 1, I should be able to go back to Dirk and see that he has a route to 10.10.3 now. And he does. It came back up. If we do show IP OSPF, we now see that the SPF algorithm was last executed 9 seconds ago. It's executed 8 times. However, Dave over here is blissfully unaware that anything is happening over in Area 1. He's only executed his SPF algorithm 12 times for 7 minutes and 38 seconds ago. Now, the last thing we'll talk about really doesn't have anything to do with multi-area OSPF. It doesn't really have anything to do with much of OSPF other than the router ID, which some might say is central to OSPF, but it doesn't really fit into configuring the normal operating parameters, i.e. you don't have to set the router ID, but it can help. So the first thing you'll do, if we do show IP OSPF, we notice that our ID is 10.10.6.1, and it picked that because it is the highest loopback address ID. If we do show IP interface brief, even though the 192.168 network is higher than 10.10, 10.10 is a loopback, and you'll recall the rules, that network always wins. However, if this loopback were to shut down, and we were to reboot this router's ID would change to 192.168.1.6. Again, that may not be desirable under certain circumstances. So you can actually go into router OSPF and the process ID, and you can use router ID and give it an OSPF router ID and IP address format. Now it looks like an IP address, and for all the world, you might as well say it's an IP address, but really you could say router ID is 0.0.0.1, and that would be acceptable because it'll accept any number there. In this case, we will actually force this router to be router ID 10.10.6.1 and exit. And you notice it didn't do anything. If we were to manually set a router ID, it would not actually change the operating parameters until we went in and did a clear IP OSPF and 110 process. And we're not going to reset it because we don't really need to do that at this point. But if we had changed the router ID to something different, that is how we would force that new router ID out to all of the OSPF neighbors. So that's pretty much it. We have gone over OSPF parameters, we've gone over configuring single area and multi-area OSPF, and that concludes our discussion of OSPF.